Assalamualaikum warahmatullahi wabarakatuh. My name is Rahmat Hidayat bin Muhammad Hashim, and my supervisor for this project is Dr. Azrina Eza Ozali. Today I'm going to present my final year project entitled Real-Time Water Level and Flood Detection System using IoT device. So, for this real-time water level and flood detection system that implement the uses of IoT device was being developed, some of the background studies related to the flood and the flood management have been done. Uh, Flash flood can be defined as a rapid flooding of lowland area. Flash flood also can happen within few hours, especially area that is near to the trench or the river. And flood occurrence in Malaysia was managed by Jabatan Pengaran dan Saliran or JPS. And the current system that was implemented by JPS is the telemetry station, which uh which was placed in the main river in the state and water level indicator for the small river. Next, I've come up with three problem statements which are there is no telemetry station provided a small river. It does not have real-time information update about the water level at a small river, and there is no notification or alert provided for public. To cater the problem that have been stated before, these are the solutions for the problem, which are to develop an IoT device that could collect the water level data of the river, develop an Android application that could update the user with the real-time data which was collected by the IoT device, and finally, the application provide a push notification for the user when the water level reach certain level of danger. Alright, next, this is the use case for the system, which mainly involve main actors, which are the IoT device and the user. For the user, mainly they can use the system to view all the information related to the system, such as the water level, the weather, which is raining or not raining, the temperature, humidity, and the precautionary measure, and finally to view the information related to the Pusat Pemindahan Sementara or PPS. And the IoT device mainly will update all the information related to the temperature, water level, humidity, and weather autonomously. And this is the class diagram for the system. And finally, how will the system work? So basically, the system will be consist of two main components, which are the IoT device and the Android app. So the IoT device prototype will be developed by using the ESP32 dev kit as the main microcontroller for the system for the device, which will later be with the implementation of the related sensors to get the data related to the flood and the water level. Next, the IoT device will be connected to the network through the Wi-Fi connection, where later all the data collected by the device will be sent to the database in Firebase. Then, to interface all the data that was collected by the IoT device, an Android app will develop where the app will receive the data and provide the notification for the user when the water level of the certain area will reach danger level. And alright, to give more understanding on the project, let's proceed to the system demo. Alright, before we proceed to the system demo, I'll give some explanation on the IoT device. First, as we can see on the screen right now, the picture in the middle is the prototype of the IoT device that I've built or developed, and that device consists of four main components, which are ESP32 dev kit, which is the microcontroller or the brain of the device. Then I attach ultrasonic sensors to detect the water level, rain sensors to detect the rain, and DHT11, which is used to detect the humidity and the temperature. All this all of these components were compiled into an IoT device where I use Arduino IDE to program the device. Next, on this page is the picture of the IoT device prototype that I've done. Alright, as we can see on the screen right now, on the top right corner is the real-time database from the Firebase, and on the bottom right corner is the IoT device that I've attached to a container to represent the river. And on the left side is the Android app that I've developed to interface the IoT device. And all the data that was shown in this demo was updated in real time by the IoT device. Alright, as we can see right now, once the water level reach the distance of 4.16, there is push notification sent by the apps. Next, I'm going to show the push notification again when the app is not on the display, but it was still running in the background. On this part, I'll show the function to update the rain information. I will spray water toward the rain sensor to imitate the rain. And as you can see right now, the information of rain have been updated from not raining to raining. Finally, to show the changes in the temperature and the humidity, I will test them by pouring the IoT device into the container filled with warm water. After a few minutes, we could see the changes in the temperature where the temperature changed from 29.3 to 36.2. However, the humidity does not have a decent changes shown, where the humidity only on the range of 79 to 80. Okay, next is the other function in the apps, which is first the precautionary measure, where in this page there will be list of precautionary measure for the flood victim, where it is the action that need to be taken before the flood, during the flood, or after the flood. And finally, the view PPS function, where in this page the user can use this page to get an update information related to the PPS or pusat pemindahan sementara information. In this page, I use the function of web view, where all the information view displayed on this page was taken directly from Info Bencana JKM website, and this is also the same information that we could get from the website. And in here, in this page, it will show the current PPS that's still open. For example, right now, the only evacuation center or PPS that's still active is one, and all the information that we could get related to bencana or the disaster could we achieve from here. And that's all for me. Thank you.